All right, good morning. We are doing teaching math with Google Slides. Here is the link to the presentation in the chat. And what I tried doing last week was putting out to let other people pick the topics. So this was one that was chosen. So we'll go ahead and go through this. This is not everything you could do with Google Slides. I could just write a book teaching math with Google Slides. That would be an easy book to write. One of my favorite tools is to just use Google Slides because it's multimedia, because it's collaborative, it's interactive. The things I don't want to use it for is to turn into a worksheet because you got to open that. Like, how is this better? I still have to scroll through them and see what they put on the line. And can't open the presentation. I thought I put this in a folder with the, and my mouse died. Keeps doing that. I guess that folder doesn't have sharing permissions. Let's try this again. Can you? What the deal is. All right, so teaching math with Google Slides, you know, one of my things that I like to say is that show your work is obsolete. If I could just have a wish is that I just never hear the phrase show your work ever again. Using photo math, and it's not just photo math. Microsoft OneNote, even just a simple Google search will not only tell you the answer to a math problem, it'll show you all the steps. So this show your steps is not critical thinking. I think my department, we would have the kids do these awful packets, and our justification for this as well. No, it has no connections to the real world, you're right, but we're teaching you critical thinking. It's like, no, we're not. If you're applying an algorithm, if you're following steps, if you're show your work and it's supposed to be the way the teacher does it, that's not critical thinking. That's just stressful because math is creative and visual. I'm going to make a slide for that. Why is my mouse not working all of a sudden? All right. Everyone knows I love Joe Bowler. Right? So if math is creative and visual, then everyone doing the same problem the same way. It's just an old school approach, and it's stressful for kids and contributes to them hating school because they don't understand it. We just ask them to do it. And one of the things that I'm trying to get across to my students this year is the first step is, I don't know. Let me think about it. And even as math teachers, you know, we give the impression that we know what to do right away, but we don't. Right? When you look at a math problem, you actually have a lot of things going on in your head that you are evaluating, taking in information, and making a decision about what to do first. And a lot of it's based on the fact that you just have experience with it and you've seen problems like it before, so you're able to pattern recognize faster. But, you know, when you first did them, you're like, okay, let me think about it. And we give kids the impression that you're supposed to know what to do immediately when you approach a math problem, which a real math problem, that would almost never be the case, is you want to do that. So I always tell the kids, you know, what do you observe? And so what I've been doing this week, because I'm teaching geometry, is I get one of these pictures with, you know, has a bunch of lines and a couple of the angles are labeled, and then you got to figure out the rest of it. You know what I'm talking about? So the first step I do is I get a Jamboard and I say, okay, just add a Post-it note. Add a Post-it note on there. What do you notice? What do you observe? What's on here? And I go, there's no answer that's too stupid. It has a white background. There's black lines. Awesome. Because success builds success. So a lot of times kids give you, I don't know, which means I'm not confident. Excuse me. I got to drink this stuff in order for it to work. Okay, right? And so I want them to get past that. Is like, I'll take anything you can observe. There's angles, there's lines. Where's the equal sign? I don't want them to start solving math problems. I want them to start thinking. And that's really a challenge to get them to do that. So let me show you an example of how I do this with Google Slides. And I do a variety of tools. This is one of them. But the reason why I like Google Slides is because it is one idea per slide that I can present my thinking rather than show my work. So someone, tweeted this out, and I thought I'm supposed to be doing something else. So of course I'm going to do this because I'm the master of procrastinating. And so I put this into a Google Slides. Someone, like I said, someone tweeted this. So my first step is that you have to take a selfie. And it could be a Bitmoji selfie. It could be insert image with the webcam. It could be a thumb selfie. Some of the kids don't want to be in there. Some of them just like to sketch something on paper, hold the paper up to the webcam. But how confident do you feel? And one of the 8 mathematical principles is choose tools strategically. So I want students to choose the tool. And so that standard says, if they need to use a spreadsheet, I don't tell them. If they need to use a ruler, I don't tell them. They should know what tools they want to try. And maybe it's the wrong tool. We've all done that. You started doing something and then you realize, no, it would be better to do it this way. But we don't ask kids to submit that. But when you make a decision or you make a statement and you're like, no, I should do it this way, or no, I think this instead, that to me is the highlight of what I want my kids to do. It's an evidence I'm thinking, I'm starting the process, I'm risk taking, and we just want kids to do it in pencil and erase, and I want them to do it in pen. I want to see the messy because it really is messy, and valuing that, I think it's good for students. So you can put Desmos into Google Slides using Equatio. So I use the Equatio add-on. This is free for teachers. It is not free for students. It is by Read and Write. Text Help is the company. So if you have a Read and Write for your reading students, it's a small additional fee to get the Equatio. For your math students, and I want to put in here, my feelings, right? To be honest, I was surprised. I thought it was a regular parabola. I want your strategy, your thinking, your feelings in there. And so then I go to the next one. I don't know if you can see this. I've got a little dot on here. So I was like, oh, well, that was surprising. I substituted a 4 into the equation. My first step is, what does a graph look like? What happens when I have 4? Well, here I did it with -4. Why did I do that? There's no reason to put in -4 other than just was curious and like, yes, show your curiosity. There should be some things in there that wouldn't be a step or things that you would do to solve the problem. And I said, I was curious. What does -4 and 4 look like? So I'm explaining my thinking. I'm explaining my strategy. And I want to contrast this what it looks like without absolute value. So I'm throwing some more graphs in there. So you notice a lot of times when we use paper or paper substitutes, we layer our steps. So when you go in to check student work, it's just everything dumped together like a cake, and you have to guess what's in the cake. So doing it with slides, it's like, okay, I did this, and then I tried this, and then I thought this, and I want them to put one idea per slide. Do you see how little is on this slide? It is one sentence. And then I want them to use tools. It's not cheating to use tools you have access to 24/7 in your everyday life. You just got to tell me what the tools are. So I'm explaining to you what tools I'm using. I have a requirement they have at least 3 selfies. They should have at least 3. And then I have a rule, you should have to Google it. It is not cheating to Google something. In fact, you are required to show me that you Googled something. We're about a month or so into school right now, and some of my students are like bragging, I Googled it. And I'm like, yes. They were doing it anyway, y'all. They're doing it anyway, but they do it under the table. Like, no, bring that phone out on top of the table. Of course you're going to Google it. We all do. I Google it. But you're going to show it to me. You're going to take a screenshot and put it in there. Like, it's clearly not a cusp. Like, so what I'm doing is I'm going through the multiple choice options. Like, what are these things? And I took calculus. I just forgot. I don't know. Look it up and explain it. Again, it's not cheating to use tools. I looked at this, I'm like, okay, I got to do the derivative. I could do that, I guess. No, I couldn't. It's been way too long since I've taken calculus that I had to by hand calculate the derivative. Why do I need to by hand calculate the derivative in 2020? I literally can Google search it. I Google search derivative of x squared minus the absolute value of x minus 4. This website came up and did it for me. We lose the forest for the trees. The kids spend all day calculating instead of spending all day thinking. Forget that. Take a screenshot. Tell me what the tool is. Link to it. Do you see here? If we zoom in. View, zoom. I think this actually makes it smaller. Yeah, okay. View, zoom, 200%. You see what it says right there? You see this? Show steps. There is 5,000 websites that will show your work. Like, these are the steps to do it. So I don't want them to show me the steps. I want them to explain the number sense. What is their logic? So I want screenshots. And what's awesome about Google Slides is you have a text box. And I want you to use that text box. Explain to me what I'm looking at here. Don't show me your work. Show me your thinking. Explain this. Do you actually understand it, or do you just know how to copy a set of steps? View, zoom, fit. All right, so then I explain this. All right, the answer cannot be A because it's not differentiable at f of 4, or the derivative of 4. All right? I share my feelings. That should be part of it. Anyway, I've got a bunch of these. I'm noticing here that it's got this line where it breaks at the derivative. I'm not trying to teach you calculus, but I really hate the word cancel. I didn't like it. So again, I'm showing my feelings. That's correct, Mindy. In this particular, it's not collaborative. It is everyone with their own. Please don't do this right now. Right, so I'm doing some more Google searching. I'm finding more tools. They're hyperlinked. And then I have a rule. It's not cheating to turn in someone else's work. In fact, it's required. It's 2020. Let's rethink what a math problem should look like. And when 1 + 1 is not 2, when you talk about math, number talks and thinking through things with somebody, you learn more math. You know, old school, we have every kid working alone at their desk. You know, more modern approach is we have them talking about it and collaborating. So they are required to show collaboration. So now this is one I was doing on Twitter. So this is the guy, he had tweeted this out. This is not my work. That's not my picture. So I like to have the students do their work on quarter sheets of paper because they can grab someone else's work, hold it up to the webcam, and stick it on the slide. And like, this is what Zach said. This is what Javier said. I agree or disagree. I want to see that they include someone else's work. I should see some sort of a note that said, Zach said, I talked with. I require that they demonstrate to me that they interacted with somebody. It might be that they interacted with me. This is not my Desmos graph. He tweeted this out, and there's the live hyperlink to his Desmos graph. And this is some screenshot of a conversation where they're saying process of elimination, so it's corner. And I'm like, I don't like this. I want to prove that it is. I don't want to process of eliminate. So I do some more Google searching, more screenshots, right? More screenshots, more Google searching, more collaboration. And finally, I'm like, oh, geez. The definition said of this is that the slope is different on each side, not that they're opposite. You know, if you ever do this, you guys, you put it in your mind. something and you just kind of fixated on that word, that definition, and you realize later that you were just thinking about it long, like the word present and present are the same word. So when you read it, you have initial like thought that this is the direction you're going. You're like, oh no, it's really the other one. When you have absolute value, it looks like this in a graph, and it gives me the impression that the slopes are opposite. But that's actually not the case. They're just different. And I'm not dumb. It took me 52 slides to figure this out. But do you see how I didn't show my work and just answer the question? I showed you my thinking, and it really doesn't even matter if I got the answer. I'll show you the next one is like that. What I like to do is to go on Twitter, and I just like to find math problems that my students have no idea how to do and they won't be able to do. I do this to them all the time. I'm so horrible. I just look for people using the hashtag math chat or hashtag MTBOS or whatever that they're doing. And they said, my students had a great discussion about this. I'm like, my kids are going to do that. So I took this problem, pre-cal, and I gave it to 12-year-olds. I'm like, I know you guys won't be able to do this. I mean, it's pre-calculus. You're 12. But I just want to see what you can figure out, right? So step one, take a selfie. Almost always when I do this with students, I get this for my selfie. It's how confident do you feel? And it's usually not good. I'm like, awesome. Okay, the next thing that they're going to do is they're going to go through and what do you observe? Now notice this, I got one observation per slide. And like I said, no observation is too stupid. Just start observing things. The line is red. That's a great one, right? There's a rectangle. There's a 6 and a 10, length and width, small sides, big sides, rotate. There's a 150. There's a weird symbol. There's 4 answers. One of the answers is correct. 3 of them are not. Math I don't understand. I shouldn't be doing this. I told them, you won't be able to do this. So they're mad. Like, what are you making me do this for? They think they're being sassy. I love this. I think this is great. So you see how this is part of the process? Maybe getting mad. I'm like, what the heck is this? It's part of the process. And yet I'm forced to. I don't want to do this. And she's like, okay, I'm done. I've got enough slides, right? If you do this correctly, you should have 40 to 50 slides. And I said, well, you are required to Google search something and have a screenshot. So what did you Google search? So here's our Google searching. She says, after I search it, I still don't understand. It's just worksheets with answers. Yep, that's what it is. I don't know anything about this. Thumbs down, no, just learning letters and numbers. And there's the next selfie, right? Because they're required to have a minimum of 3 selfies. We come back to the problem. What I love about Google Slides is I can grab a slide, Control-D, duplicate, put it down here. So here's an Annie Fetter technique is you give kids math problems where you don't ask the question. Delete the question. We want students to approach math by thinking, not approach math by trying to solve the answer. We're teaching them to be mathematicians. We're not trying to find the answer to a question. None of these are real questions. So I deleted the question. I said, well, what could you find? Like, well, I can find the area and perimeter. I don't know why. Fine. Great. So she's finding the area. She's finding the perimeter. There's still no answer. I said, what is the question? Then we copy and pasted the original slide again. The question is, what does continuously rotate around a straight line mean? So I said, great, Google it. This comes up. Whoa, you see this? Whoa, like an epiphany. She's so ticked off. She's angry. Why am I doing this? This is stupid. She finds a Google search that shows her like, hey, if you rotate this, you get a cylinder. So then we have to show collaboration. So she turns to the student near her and says, what do you think about this? And that student's like, well, I would do volume. And my 12-year-old's like, well, I don't know how to do volume of a cylinder. Awesome. My rule is I don't tell you things you can look up. So far, I've told her nothing. All I do is I poke them. I'm like, okay. So she finds these pictures off the internet. And then she gets this website. And we have the link. You have to have the live link to the website. So now she's got this picture and she has figured out what the radius is without me saying anything to her because it's 2020. Use your resources. I ain't one of them. She says, I think my radius is 33 because, y'all, that's all I want in life. That is all I want in life is the word because. I think this because. She says 33 because that's what the perimeter was. Beautiful. It's completely wrong. I don't care. Like, all right. Now, this is Joe Bowler technique, right? You cannot rescue students from thinking. It's not my job to rescue kids from thinking. And so you got to put on poker face. Whatever they say, you got to have poker face. Okay, so what are we going to do to find the, go ahead. You think it's perimeter? Do perimeter. So I just held up an index card because my goal here is to tell them as little as humanly possible. It is not my job to rescue them from thinking. So I just held up an index card and I waved it. And then she figured out that the radius is 10 and the height is 6. And, you know, we're not here trying to see if they can crank out the volume formula. There's a calculator for that. You should use it. So we put it into the calculator. Mindy, I do not watch them do this live. It is a process over time where I give them feedback and then they continue to work on the same problem. And she says, oh, I swear there was a tiny fist pump. You know, she doesn't want to admit it, but, you know, thinking feels good, you guys. Feeling dumb does not. And success builds success. So she's starting to see some things and some patterns. She says, I rotated the shorter side and that did not work. Do you see how it gets its own slide? It gets its own slide. Everything is spaced out and it's this, and then this, and then this, and then this. And it's a journey of their thinking rather than showing their work. Seriously? Go away. We've had many conversations that they just need to be other places. Okay, rotating on the long side doesn't get me 150 pi either. So I think the radius is just 3 if we rotate it through the middle. And you know what? She's 12. She doesn't understand what pi is, and I don't care, right? That's not even the purpose. So she has figured out that she needs to rotate it through the middle. She has figured out, she didn't figure out the answer. Well, I guess she did in terms of the math, but she figured out the thinking and she was able to solve this calculus problem. And I told her nothing. I just kept telling her, well, Google it. What else can you figure out? And this 12-year-old was able to do this calculus problem. And I have one more. Nope. That's the same one. Dang it. All right. This one. This is the one I meant to do. I'll link this on the slides. Okay, so again, I gave this geometry problem to my geometry students. And babe, please go outside. They don't know this. They haven't learned it yet. This was early on in the year where they haven't learned these angle relationships. But again, I wanted them to approach a math problem with, I don't know how to do this, but rather I could figure this out. So my first step is you have to take a selfie. How do you feel about this? This is fairly typical. I don't tell students to use Bitmojis because there's some very inappropriate Bitmojis, but if they already have it and it wasn't my idea, they're certainly welcome to use it. And so then what do they need to do? They need to brainstorm. Give me a list. What do you notice? Tell me everything you notice. Now, I would have rather this be on individual slides like the last one, but that's fine, right? There's 2 labeled angles. There is no observation that is too stupid. Start with the stupid ones. Because what students are like, I don't know. I don't know what to do first. Exactly. So just tell me, there's a star. Awesome. There's a star. The lines are blue. I love that. Keep going. You know, and you just like let them get all the stupid ones out. I don't think they're stupid. We observed those things too. We just didn't say them out loud. Get it out, and eventually they start to make some more relevant observations. I didn't say this to her, but she realized she needed to know more about triangles. She looked it up. It's not cheating to Google search it. In fact, you are required. Just give me a screenshot. Collaborate with the mom, because you have to show collaboration. Another screenshot of a Google search. So now what we've done, we copied the shape, we've inserted it, we've used the drawing tools in Google Slides to make some observations and statements. Now, this is what I do, is I add feedback slides. So Mindy, now I don't typically do it live, although the first few times, sometimes I'll sit next to a kid and have some other kids near me as well. But when I go in to give feedback, I add a purple slide because purple is my color, so you can easily tell where the feedback is. So do you see that I've got students, and then my feedback slides are all in purple. So you can tell what's my work, what's their work. And you can see on this one that I added a comment onto her slide, but I made the text box purple. And anyway, it goes on like this. And so you know they've got their 3 selfies. They're including collaboration. They're including what tools that they used, and they're just working through a messy process where I'm not trying to figure out what they're thinking. They are trying to communicate to me what they're thinking, and I promise that it will be terrible. Got that one. So my steps are: you have to take a selfie. You start with a selfie. Right, they have to have a minimum of 3 selfies. First thing you do, brainstorm. Define selfie. It's a picture of yourself, and it could be an actual picture or a Bitmoji or a sketch, something that represents you and your feelings. Brainstorm out what you notice. You should have, end up with 40 to 50 slides, and it's one idea or one thing per slide. So going back to the second one, see it's rectangle 6 and 10. I want each slide to be very minimal. Some skills that you have to teach the kids is how to duplicate, grab slides, duplicate the slide, get the picture, copy paste the picture, enlarge it, shrink it, some things like that to help them to clearly communicate their ideas. They have to Google search something. They must turn in someone else's work. They have to tell me how they collaborated in some aspect, and having a screenshot or a picture of someone else's work included is highly valued. And it's not cheating to use tools you have access to 24/7 in your everyday life. I know I'm not popular when I say this, but when I'm asked, like, Alice, how do I keep kids from? Just don't finish that sentence. Just don't finish that sentence. You know, you're going to just play whack-a-mole. You're not going to keep kids from. They're going to do those things. And so instead you design the activity where everything is open internet. Looking for silver linings here, we are in a situation where your constraints are the kids have access to the internet. Now what? The wrong question is, how do I control this situation like they were in my classroom? No, they're at home. And you can lock down your browser, but they have their phone. Questions? So Gabby, at first, you're going to get them, they'll do 3-4 slides. It is a process to get them to do them in as much detail as I have on these, where they're really, on this particular one, I was sitting next to the kid and walking her through the steps. And we did this in more than one sitting, but I was doing the typing. I'm like, what else do you notice? I add a new slide. So the first things is as many things. When you're learning to ride a bike, you fall off and skin your knees, is to have low expectations. At first, I will take any thinking. I give them some feedback and I expect them to get better in this process. But the trick is that I give them a problem that they don't know, that they have to figure it out. I don't do this for DOK1, do your homework. I do this one for, well, what can you figure out? It's not uncommon for me to give them things that they don't know. Like, I never gave them a definition of this. And I shouldn't have to. They can look that up. It's just a different mindset of, okay, I don't need to. I want to get rid of this too. I do, you do, we do. No, I do, we do, you do, right? We turn that around. We start with you do. You do it. See what you can figure out. We're going to start with the students doing the thinking. Then we are going to talk about and look at some of what people did, give some suggestions and feedback, because one of the mathematical principles is critique the reasoning of others. And then after I see what they did and after we had a discussion, I figure out what I need to backfill in. I totally tell them things. I totally do direct instruction. I just do it third. Right? It's engage. What are the 5 E's? Engage, explore, explain, extend, evaluate. So we start by having students engage in something interesting, like, why would you care about this? I have them explore a concept. My favorite example is, of course, the one from Joe Bowler's book, Mathematical Mindsets, where this calculus teacher comes in with lemons. The kid's like, why do we have lemons? Engage. She says, find the volume of the lemons, explore. They do it in small groups. They share out. We value different approaches and we value thinking. Not so much that you figured out the answer. We're trying to teach kids to be thinkers, not calculators. And when you know it, not one of the kids figured out calculus. And she's like, you guys, those are all really great approaches to figure out the volume of this lemons. But, we have this thing called the integral. Wait, what? There's an easier way to do this? Can you teach us this integral thing? So she does a full calculus lesson. She teaches them how to do the integral. It's direct instruction, but she does it third. It's not our job to rescue them from thinking. So I'll start by giving kids a quizzes of things that they don't know. Turns out they do know a lot of stuff. Some of them repeated the class. Some of them have done things before. And sometimes, it's not that hard to figure out. They can figure it out. So I don't want to start with, let me bore you to death with definitions that you're going to copy down. I want to figure out what I need to tell them, not front load what I think I need to tell them. And oftentimes I'm wrong about what I think they need to know. Engage, explore, explain, extend, evaluate. So Mindy, you can totally social distance because we're doing it on Google Slides. They can share slides. They can be on the same slides. What I'll do is I get a spreadsheet and I have them add the link to their slide to the spreadsheet so they can click on each other's slides. You can also just in Google Classroom, because when it's assigned through Classroom, I have access to it from my Google Drive. So I just create an assignment. I create an assignment, make it ungraded, and I just grab the student slides from Google Drive because it's in my Google Drive. Oh, Sandy, you can totally do this with 5th grade and kinder. You know what's awesome about slides? Voice typing you can do voice typing. They can just voice type their ideas down in the speaker notes. But the students can very effectively collaborate in Google Slides when they're not together. I mean, I'm in Kansas. Where are all you? Not here. You do things with people all of the time where you're not in the same place. And Google Apps makes that very feasible. I was working on a doctorate online and my classmate was in China. One was in China and the other ones were in Vermont, I think, for our group. And I think I had the best group collaboration on that project, even though they're in China.
Alice, can I ask a question?
Yeah. course.
When you're doing this with your class, do you have like 2 kids per, like, do you have all the kids on this slide here, or do you separate them to collaborate?
This is an individual activity. They get a copy per student.
Oh,
if I open up a copy per student, I want it to be worth my time, where I'm helping develop them as thinkers. So this is the kind of stuff that I do that's make a copy for every student.
And then how do you view everybody's?
I'm not doing that. I do not check answers.
Okay, but how do you view everybody's slides?
I open them.
Okay.
I go into Google Classroom, I click on the little folder icon, and you can see everybody's slides all at once.
Okay, yeah, all right, thank you.
Google Classroom is I have access to it before they're done. So one of my rules, I tell students, you don't submit work, you submit for feedback. So, I give them time, like, let me remind you, got to do a selfie, brainstorm. What do you notice? What are things you think and see? Get the first start, and then I can go in and add those purple slides.
Yeah.
Giving them some feedback, and then we come back and do this again. This is not a one-day activity. This is a 3-week activity.
Oh, okay.
We do one problem really well over time.
Yeah.
And I have a solid rule that I don't give kids, I don't assign myself paperwork that I can't keep up with.
Yeah.
Because feedback is a double-edged sword. It is really motivating for students when you're giving them feedback and they are able to respond to that feedback and feel like they're making progress. But if you're slow about it, then they're just ticked off. They don't care anymore if you don't have a almost chat conversation. So when I look at part 1, I'm like, okay, you guys are going to get started. Just dump anything you notice. Get your selfie in there. See how far you can get. And then now it's my turn that I got to go in and give some feedback to them to help them take another step, right? Now, when I'm in person, I'm going around and I like to sit with the kids and we talk about them together. So you don't always see the purple slides because sometimes I'm doing it in person. Sometimes I'll take one kid's slides, I project it, and as a class, we discuss through it and we give one student feedback together, because you need some strategies here. You can't do it all yourself, nor should you. The feedback burden should not be yours. The person doing the work is the person doing the thinking. No, learning. The person doing the work, the person doing the thinking is the person doing the learning. However you want to word those together. But I should be facilitating students having conversations and really poking them to think more, not, hey, let me do this for you, or I'm doing all the feedback and the grading. We should do it together. So a lot of times I like to use collaborative Google Slides where we're all on the same slides, because now the feedback comes from us talking about everybody's work instead of me going home and doing it by myself. And the next day after they've slept on it, thinking they're going to care about my feedback tomorrow. So in these, I'm like, okay, I'm going to work on this tonight where I'm going to give feedback. So then that's where I'll have them. I move the assignment up in Google Classroom that they revisit those slides. And if I know, like, well, tonight I'm going to church, so I don't have time to give feedback tonight, then that's not the activity we work on today. We do something else. But this is something we do over time. And they're terrible, and I'm trying to develop them as thinkers and get them to do these things eventually. So and I don't need them to finish them. That's a really important thing. I'm trying to get them to show thinking, not necessarily that they answer it. Sometimes we'll do these, I'll do some feedback, they'll make revisions, I'll do some feedback, and then I'm just like, we're moving on. I'm doing a different problem. But I only do one at a time. Once I get students to do a process, and I know that, I know you know how to plug numbers into y equals mx plus b, then I don't have them do a whole bunch of problems like that, because I already know they know how to do that one. I give them a few other problems where there's a twist on it, and I say, just do the first step. Tell me what strategy you would do first, And that's all I want. Once they have that, I know they know how to follow all the rest of them to get down to the answer. But that's where you start to get this fatigue, right? Because you're like drooling, doing the same thing, doing the same thing, doing the same thing. Thinking is motivating. And so I find reasons to have them share their thinking, share their strategy, and that's all I want from them. So maybe have 2 problems that they actually do it, and then have 3 more where I'm just like, what's different about this one than the other one? What would you do? Just tell me. You don't actually have to do it. And I find that that helps a lot. So in this particular, I do a lot of strategies when teaching math. I do a lot of strategies. This is one of them, is that I invest in helping kids think through something they think they can't do or they think is challenging. Try to do some DOK3 here, strategic thinking. And it's time consuming. It's over time. And when you cycle back to things, so doing, I think this is a Joe Bowler quote, if doing 30 problems was effective, we'd all be good at math. You know, after you've done 2 or 3, you're no longer thinking, you're just cranking stuff out. It's actually very unproductive. So we're going to do the 30 problems over the semester. We just keep coming back to it. So I just make all of my assignments spiral. We just keep coming back to it. We keep coming back to it. We do a problem together in class. I don't give homework. I want them to forget it. And they come in, I got a quizzes or something for them to do it again. They do terrible. We go over it. We retake it. They do better. But that spaced repetition, give them a break between doing it, puts it in their brains a little better.
Where do you get your problems from, Alice?
Oh, I Google them. In fact, let me show you what I did the other day, only to figure out that I didn't know how to do it. It was hilarious, but then at the same time, I love it. I gotta find where I put this. Hold on. So I guess switch to my school account, and yesterday we did this. Let me share this with myself. Oh, this wasn't the right one. Oh, although I'm going to leave that open because maybe we can do that one if we have time. It was this one, I think. All right, let me look. Okay. I did this as a pair deck. Was Instructor Paste. We were doing it together. And first this is from Unit 1. So again, I like to spiral back. We just keep coming back to things we had done before. So can you tell that the years are congruent? So then we got to this problem. So I asked them, what's one thing you observe? And I'm looking for them there's 2 triangles. There's black lines. Some of the sides are marked the same. And then I prompt them, what's one thing you can figure out? So a lot of the students figured out that this big triangle, they could get this angle up here. So then I asked them, well, are the 2 triangles congruent?
Was that like a text question?
I got this off the internet. I just Google searched it.
What, the pair deck thing?
I made this.
Yeah, what I'm asking is, was that like a text insert or something from pair deck?
I'm not sure I understand. They can draw on that slide.
Oh, they can draw. Okay. Thank you.
No, that one might be writing. I don't know. I just wanted them to be like side, angle, side, angle, side, angle. So I think it was a type your answer. But then I'm like, okay, well, if you're going to do triangle congruence, what do we know? We know that, I have the web paint on here. Yep. I just turn on the web paint. Yeah, okay. Right? We know this side and this side is congruent. And then we know that we love this when they're the same, they share a side. Just be on the lookout for that. All right, so we have a side and a side. Can we solve triangle congruence with side and side? And of course, the kid's like, no, we need side, side, side. I'm like, all right, so what do we have? We do, and actually, all these examples that I gave, all of them, they didn't have enough information. I, on purpose, want to give them things where there's no solution. They can't figure it out. They don't know enough, because I want to get away from this mindset of follow the steps and get the answer.
Alice, what is that thing you just called it? Web paint?
Yeah, web paint. So,
is that an extension?
So then I'm co-teaching with my other teacher.
Thanks, Gabby.
I'm co-teaching with my other teacher, and I'm like, what is the next step? Because I realize I don't even know what to do next, because this is what I get for pulling stuff, random things off the internet. And when the kids left, my co-teacher and I sat down with some paper and we labeled all the angles and tried to figure this out. There are 4 unknowns. There are 4 angles we don't know. We were able to write out 4 equations, which means it's solvable. And then I started busting out writing a matrix, which is algebra 2. And he's like, are you seriously using a matrix? I'm like, I don't want to, but I might need to. And then the first time in my life, I felt like I wanted to use a matricy. But I love stuff like this because I don't want kids to think I know everything. We think through things together, and sometimes I don't even know what to do. All right. I'll share this other one with you that we did yesterday. Oh, done. I did that wrong. Okay, got it. Copy. Let me share this with myself. This one was also Pear Deck. I did in Google Slides. I mean, Pear Deck. That's the way it works. So first I just did this part of the Pear Deck slides. I could just have them drag it. I don't know. And then I said, okay, go to geogebra.org/notes or use a quarter sheet of paper, sketch this out. And the first thing I want to know is, what do you observe? And no observation is too stupid. And then what do we know and what do we need to know? So then I had them find Q. They can draw on these slides. Pear Deck lets you do that. And then we find all of the angles. So I'm just trying to get them to think through the justification. I'm showing other students. The Pear Deck lets me show other students work that, and I like to focus on the ones that are not correct. And that is a Joe Bowler technique, because I like how you were thinking. And Carol Dweck in Joe Bowler's book said, oh, did you get the right answer? What a shame. It's a much more interesting conversation if you didn't get it right, but it's not that you're wrong, as you're thinking. So let's talk about your thinking, because this is not nonsense. That was a good thought. I can see how you would think that. Given this information, how might we build on it? And I get the kids to have conversations around those. And in Joe Bowler's book, she describes it's work. It's hard. You get kids to the point where, well, Miss, I got it wrong. Share mine. Let's talk about mine. And just try to develop those conversations. Less around, I'm not interested in getting the answers. This isn't a real thing. I'm not building anything. It doesn't matter if I get the answer. What matters is if I can get the kids to think through it. Okay. What else can I answer for you? Well, that's a different topic, Mindy. But you can use Jamboard, you can use Google Slides. Definitely do number talks. I'm in love with GeoGebra Notes, although that's not collaborative.
Maybe that can be the next topic for a webinar.
Sure. That's probably my biggest problem is people like want me to teach everything in an hour. I'm like, this needs to be way more narrow and even narrower. It's like picking a dissertation. You know, you got to do Italian door knockers from 1732. I mean, even though it's going to be a book, literally, it's got to be super specific. So,
Thanks. That was a lot of lovely food for thought.
I hope it was helpful. Let me give you the slides again, so you have the links.
Thanks, Alice.
Alice, this is great. Thank you.
Yep. Thanks, everybody. Have a great Saturday.